In northern Canada, North American river otters endure the cold and snow to take advantage of the excellent fishing spots found here. 23 million years ago, another small aquatic mammal lived a similar fishing lifestyle in the cold rivers of Canada. It walked on frozen ground to reach other waterways. But although this creature resembled an otter and lived like one, its skull had a different shape, and instead of 6 front teeth like an otter, it had 4. These features and a few others revealed its true group. Its name was *Puella darwini*, and it is the oldest known seal. Welcome to the Brainy Animals channel. In this video, we'll talk about the evolution of seals. Seals, scientifically known as pinnipeds, are carnivorous mammals closely related to dogs. Their closest relatives within this group are not river otters. River otters are just a separate branch of aquatic mammals that are more closely related to badgers and weasels. The closest relatives of seals are actually bears, and they likely diverged around 40 million years ago during the Eocene period. Although *Puella darwini* is the oldest known pinniped, it was probably more adapted to aquatic life than river otters are, and likely swam in a different way. It had very large hands and webbed fingers. Its hands were long relative to its body size, which means they were probably flipper-like. However, their tails don't seem to have been specialized for swimming. This means they likely moved in the water using their limbs, while river otters use their flat tails. This makes sense because modern seals use their flippers for swimming, and not their tails like river otters and whales do. This is a method of movement in water that seems less common among terrestrial animals that evolved for aquatic life. And seals share this trait with marine reptiles like plesiosaurs. There was another seal resembling a freshwater otter called *Ptamotherium*, which means river animal. And it also had this trait that seems to be common in terrestrial animals. There existed a species known from France and Germany, which shows that these freshwater lake seals were successful and spread across the northern hemisphere. The first seal that resembled modern seals appeared about 23 million years ago in the early Miocene, but freshwater river animals continued to live until about 10 million years ago. The existence of otter-like seals and marine or lake seals overlapped for a long time, and freshwater river animals were a separate branch of creatures that had their own way of life. Only the marine seals have survived to the present day. The first seal to enter the sea was called *Arctos*, and it likely swam along the western coasts of America. It had a short tail and short legs that could probably be called flippers. This means it was the first seal to start resembling modern seals. However, its femur was still nearly twice the length of modern seals, meaning its hind legs were still large. Its femur would eventually shrink to the point where it became more like a jointed bone. *Arctos* used both its front and hind limbs to move in the water, which actually helped resolve a debate among scientists about the families of living seals. Modern seals are divided into 3 families. The first group is the earless seals, which include the more advanced seals without ears, as well as most Antarctic seals, such as leopard seals and elephant seals. The second group is the eared seals, which includes seals like sea lions. The third group is the walruses, which have only one living member, the walrus. All these animals use different methods to move in the water, leading many scientists to conclude that seals evolved from to terrestrial branches. Eared seals use their front limbs to move in the water, while earless seals use their hind limbs. Walruses use both. If *Anale arctos* was the common ancestor of all modern seal groups, then eared seals must have stopped using their hind limbs, while earless seals stopped using their front limbs, and walruses might have diverged earlier than the other two groups and retained the use of all their flippers for swimming, which resolves this mystery. Despite *Anale arctos* having many specializations that made it more adapted to swimming, it was probably more reliant on the shore than modern seals are. This is because its teeth were more similar to those of terrestrial carnivores like bears, and they were more suited for cutting rather than piercing. This means they likely had to return to the shore with their prey before tearing it apart and digesting it. A seal called Guietaria crypta*, which lived around 16 million years ago, marked the beginning of modern seals. It shows a transition between bear-like teeth and the teeth of modern seals, which freed them from the shore and allowed them to swim for longer periods. Music ***. At night we say with Mufasa, cursed day, I balanced the grain to the edge of an oath and nuclear conflict. And this singular good is a source. Disney's Mufasa, cursed day. Rated PG, I will restrain again. During the late Oligocene and Miocene, ocean ecosystems were changing and starting to evolve into their current forms. There was a sharp increase in the number of toothless whale species. Penguins had spread across the southern hemisphere. Echolocating dolphins appeared for the first time, and now seals had also entered the seas. The first dolphins, like Kentriodon, may have competed with seals for fish. There's evidence to believe that dolphins might have been better hunters, as they had echolocation and were almost always faster than seals. However, seals have very flexible spines, and although dolphins are often more agile, this flexibility may have helped seals with hunting slower or more maneuverable fish. The adaptation of seals to maneuverable prey and slow-moving fish is evident in their flexible spines, which can be traced back to **** and Alircetos***. Another advantage seals have, which toothed whales lack, is their ability to come onto land. This is useful for escaping predators, and can also be used for hunting. Leopard seals are one of the few seals adapted to eating larger animals and fish. Unlike orcas, they can hunt penguins, both in the water and on land. Seals and other marine animals that appeared during the Miocene provided new food opportunities for larger predators. One notable group of new apex predators was the ***leviathan* whales, close relatives of modern sperm whales. Unlike today's sperm whales that feed on squid, the ***leviathan* whales targeted marine mammals like seals. Modern sperm whales use a suction feeding mechanism to capture their prey, crushing them when swallowed. Their teeth are only on the lower jaw. Designed primarily for holding prey during this process. However, clear evidence shows that ***leviathan* whales did not feed this way. They had stronger and larger jaw muscles, and much bigger teeth on both the upper and lower jaws. Their teeth were sharp and specialized for grabbing prey, allowing them to tear apart and crush seals easily. During the Miocene, baleen whales diversified significantly, and by 4 million years ago, they had started reaching the massive sizes we associate with them today. As baleen whale diversity decreased, this may have contributed to the extinction of apex predators like the ***megalodon** and ***leviathan**. with the end of the era of super predators. New, smaller oceanic predators, like killer whales and great white sharks, focused their attention on seals, becoming specialists in seal predation. Thus, seals have exerted evolutionary pressures that have reshaped oceanic apex predators. Seals have not only shown us an extraordinary adaptation to becoming aquatic animals, but they have also driven the evolution of other creatures and played a vital role in shaping today's ocean ecosystems.